Hello everyone, this is Subhashmita Majumdar from IIPS DAVV Indore, and here I am to give the solution for the question. Give 4 comparison among various iterative methods: bisection, regular falsi, secant, Newton-Raphson and successive approximation method. Now starting with the comparison, the first one is comparison on the basis of iterative formulas. So first, bisection method. The iterative formula for the bisection method is xi plus 1 is equals to xi plus xi minus 1 upon 2, where xi and xi minus 1 enclose root. The false position or the regular falsi method has the following iterative formula, which is equals to xi minus 1 fi minus xi into fi minus 1 upon fi minus fi minus 1, where xi and xi minus 1 enclose root. Newton-Raphson method has the following iterative formula: xi plus 1 is equals to xi minus f of xi upon f dash of xi. Secant method has the following iterative formula, which is equals to xi minus 1 fi minus xi into fi minus 1 upon fi minus fi minus 1, where xi, xi minus 1 need not enclose root. Now for the successive approximation, the iterative formula is as follows: xi is equals to g of xi minus 1. Now comparison on the basis of order of convergence. So starting with the bisection method, in this method we take 2 points x0 and x1, which encloses the root if f of x0 and f of x1 are of opposite signs. We bisect the interval x0, x1, and by repeating this procedure, we always enclose the root in the search interval, that is x0 minus x0, x1. This search interval is halved in each iteration, and therefore the average rate of convergence is half. Each iteration takes us closer to the root by one binary digit. But for these other methods, according to convergent order theorem, an iterative algorithm is kth order convergent such that limit I tends to infinity into ei plus 1 upon ei to the power k, which is less than equals to m. This is a generalized equation, as we can see. So if we suppose y as a root of fx equals to 0, so let xi is equals to y plus ei, xi minus 1 is equals to y plus ei minus 1, and xi plus 1 is equals to y plus ei plus 1. Therefore, putting these values in the iterative formulas and comparing them with equation 1, we can get the value of k, that is order of convergence. So, order of convergence of false position method is equals to 1. Order of convergence of Newton-Raphson method equals to 2. Order of convergence of secant method is equals to 1.6180, which is approximately 1.62. And order of convergence of successive approximation is equals to 1. Now comparison on the basis of evaluation of functions per iteration. In bisection, false position, secant and successive approximation methods, only one function is evaluated per iteration, that is f of x. In Newton-Raphson method, two functions are evaluated per iteration, that are f of x and f dash of x. Now lastly, on comparison on the basis of reliability of convergence. Convergence is assured in the bisection method, as we always keep the root enclosed between approximations to the root. In false position method, it is guaranteed to converge faster than bisection method. In Newton-Raphson method is sensitive to starting value. It converges fast from any other point if starting point is near the root. So these were the comparisons of the various iterative methods. I hope this video lecture was beneficial for you. Thank you and have a nice day. Bye.